A. The maximum kinetic energy of the emitted electrons. The work function is the minimum energy required to remove an electron from a metal. When light is incident on a metal surface, the energy of the photons can be absorbed by the electrons in the metal. If the energy of the photon is greater than the work function, the electron can be ejected from the metal with a kinetic energy equal to the difference between the energy of the photon and the work function. In this case, the work function of cesium metal is 2.14 electron volts and the frequency of the light is 6 × 10⁻14 Hz. The energy of a photon is given by E equals hf, where h is Planck's constant and f is the frequency of the light. Plugging in the values, we get E equals 6.63 × 10⁻34 Js, 6 × 10⁻14 Hz, equals 3.98 × 10⁻19 J. The maximum kinetic energy of the emitted electrons is then key_max equals E phi equals 3.98 × 10⁻19 J. 2.14 electron volts, 1.6 × 10⁻19 J per electron volt, equals 5.54 × 10⁻20 J. B. Stopping potential. The stopping potential is the minimum potential difference that will stop all of the emitted electrons. This occurs when the kinetic energy of the electrons is equal to the potential energy of the electric field. The potential energy of a particle with charge q in an electric field with potential V is given by P equals QV. In this case, the charge of an electron is -1.6 × 10⁻19 C and the stopping potential is V. The potential energy of an electron at the stopping potential is then P equals -1.6 × 10⁻19 CV. The kinetic energy of an electron at the stopping potential is equal to the maximum kinetic energy, which we calculated in part to be 5.54 × 10⁻20 J. Setting these two expressions equal to each other, we get -1.6 × 10⁻19 CV equals 5.54 × 10⁻20 J. Solving for V, we get V equals 0.346 V, C. The maximum speed of the emitted photoelectrons. The maximum speed of the emitted photoelectrons is the speed of an electron with the maximum kinetic energy. The kinetic energy of a particle is given by key equals 1/2 mv², where m is the mass of the particle and v is its speed. In this case, the mass of an electron is 9.11 × 10⁻31 kilograms and the maximum kinetic energy is 5.54 × 10⁻20 J. Substituting these values into the equation for kinetic energy, we get 5.54 × 10⁻20 J equals 1/2, 9.11 × 10⁻31 kilograms, v². Solving for v, we get V equals 3.32 × 10⁵ meters per second equals 332 kilometers per second.